Hi, this is Ms. Delosier, and these are your notes on the evolution of resistance. And I don't mean the evolution of like resistance fighters. So when we're talking about resistance, we're talking about resistance to chemicals and antibiotics. So I know that you've all heard of antibiotic resistance, and this functions in the same way. It happens in the same way as the example that we're going to talk about. We're actually going to talk about the evolution of pesticide or insecticide resistance, though, because it's just not talked about as much, so I want to do the video on that. So, like I said, this happens in bacteria and it happens in what we call pest species, so insects and rodents. You can see this in both of those types of populations. So the first thing we need to do is we need to start with a population. So we're going to start with a population of ants. And we've talked about it before. There's genetic variation within all populations. So in this population, we're going to be looking at the genetic variation in their resistance levels. So in the ants that I drew here, the red ant is the most resistant and the white ants are the least resistant to some chemical, whatever the chemical is that we're talking about. So in this case, we're going to be talking about an insecticide, and you don't have to worry about the specifics of what insecticide it is because this will happen with all insecticides if given enough time. So when you have an insecticide and you use it to go ahead and spray your pest species, so I have super insecticide here, and I'm going to go ahead and I'm going to spray that on my ants. What will happen is the organisms that are the least resistant will die the first. So whichever ones are the least resistant to those chemicals are going to die first. So that's going to be the white ones, right? Now, those light pink ones might not be resistant enough to go ahead and survive, so they're going to die off also in our example. And that's going to leave the organisms that are the darker pink and the red. So those ants are going to survive, and since they're going to survive, they're going to reproduce. So the following generation, what I end up with is the pink, the dark pink, and the red ants reproducing, and basically I'm just going to double their numbers for this. So we're going to have exponential growth within our population. And now if you look at our next generation is entirely resistant. They're not all at that most resistant level, but they're at least at the moderate resistant level. Now, if I go through and I spray them again with super insecticide, I might kill off some of the pink ones, but probably not because they already survived. So you see that that insecticide is no longer really useful against that population of ants. And we're doing this all of the time with all pest species and with bacteria. So when you go to the doctor and he or she prescribes an antibiotic for you, what's happening is you have bacteria in your body that are naturally resistant to antibiotics, different levels of resistance to those antibiotics. And so when you take the antibiotic, you're killing off all of those bacteria that are not resistant to that antibiotic. But what's happening is you're creating an ecosystem for those that are resistant where exponential growth can happen. So now all of a sudden you're going to have only bacteria in your body that are resistant. And bacteria have ways that they can pass those genes between one another so they can actually share that resistance with other bacteria in the future. So this leads to the creation of those superbugs that we hear them talking about on the news. So you'll end up with bacteria that are resistant to multiple forms of antibiotics. So it's just something that you should think about before you go to the doctor and request an antibiotic or before you spray your lawn with a super insecticide. That you're really just creating organisms that are more resistant to the chemicals that you're using to kill them off. And this is an example of natural selection in action. These organisms are best adapted to survive that particular ecosystem and the harsh conditions in that ecosystem. Now, because it is caused by human interactions, you can kind of think of it as artificial selection, but we're not actually selecting for traits that we want. We're spraying the ants with the super insecticide and they're becoming the population's becoming very resistant, but that's not something we want. Artificial selection, we generally talk about that in terms of we're selecting for a desired trait, and this is definitely not a desired trait. So I hope that helps you to understand how insecticide resistance and antibiotic resistance occurs, and if you need some help understanding that or just some further examples, come see me in class. Thanks.